Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics. Today we will continue with the time series modeling. In fact, in the last lecture we have discussed about the various methods through which we can do the time series prediction. That too we have discussed freehand curve, semi-average methods and moving average methods. And every time we will find there is a kind of improvement. Of course, you can start with a particular problem and then draw the predicted line through freehand curve, then draw the predicted line with the semi average and draw the predicted line with the moving average, that too maybe with the 3 years, maybe 5 years, maybe 7 years. So, that means these are all various options again, and you will find means theoretically there is a high chance that getting the trend line through 7 years moving average will be much better than 5 years moving average, then 3 years moving average, and then what we can call as semi average. Here only 2 data points through which you can do the prediction, and then simply by inspection you have to just draw the curve by checking the highest peak and lowest peak, that is called as freehand curve. So, so that means these are all various mechanism through which you do the prediction, but the last technique which you like to discuss right now is called as a least square mechanism, which is much better than the freehand curve, semi average curve, means semi average mechanisms, and then moving average mechanisms, that to all forms of moving average starting with 3 years, 5 years, 7 years. So, now we will see how the least square mechanisms can help us to get the trend lines or predicted lines through which you can do the kind of engineering predictions, any kind of engineering predictions, and the trend line will be, or least square mechanisms will be very helpful to get the trend lines, and substantially this is very substantially better than other methods compared to freehand, semi average, moving average, and again within moving average all kinds of variations starting with 3 years to 7 years or so on. So, now what we can do technically, we will just check the least square mechanisms through which you can actually do the prediction. So, it is actually more or less seems like bivariate, simply bivariate regression. What is happening here? So, we have actually data, that too let us say production data, that is one variable in fact and time that variable is having actually a information with respect to different point of time. But what we have discussed earlier, for simple regression modeling you must have at least 2 variables, let us say y x or y x 1 or something like that, but here it is the variable is simply y, and that too we are doing the predictions. Again, when you use log variables, this simple model can be turned into a complex by moving towards trivariate and multivariate in nature. What is actually best part of this particular process is that we have the data of a particular variable, that with respect to time, and we can actually use now least square mechanism through which actually we do the predictions of that variable subject to the time series structure. So, let us see how is this particular setup. So, here actually it is more or less same. So, like we have discussed in the case of 2 variables, say y and x, like this. So, the predicted line will be like this. So, y c is equal to alpha plus beta x, alpha is a parameter and beta is a parameter, and then using these informations you can easily actually predict y. So, that means actually is a 1991 to 1995 out of big cluster, we are just taking the few cluster. So, here what is happening? So, let us say it is a 1991, then starting 1992 and go ahead with the 1995, right. So, it is 8, 9, 9, 8, 9 and 16. So, this is how the data information, and what we will do actually, this is what actually y, and what is the predictor structure here? We just take the predictor y t equal to a plus b t. So, that means the t will be used as a used as with reference to time only. So, that means this time component by itself will be treated as a particular variable to draw the trend line. So, otherwise it is actually more or less same. So, we have a y data. So, now since there is no x, so x will be represented as unit of time, that too it is a independent variable. So, that means, so this is a independent variable and t is the trend value, that is what the predicted. So, that means y is the variable that will be that will be predicted subject to function of time, that is what the a component is called as x here. And as usual simple regression modeling. So, we look for the alpha parameter and beta parameter, and here the values of a parameter and b parameter through which you can draw the line. So, now what we can do here? So, we will check the particular issue, and then we actually draw the conclusion. So, how we can obtain this one is very interesting. Same thing actually, we just add a component simply let us say there will be error term. So, that means starting will be like this. So, let us the model will be y equal to simply a plus b t and then error term, and then what will you do here? So, we minimize the error term, and that to where y hat equal to simply a plus b t, and then y minus y hat equal to say error term, that to y minus a hat minus b hat t, and this is what the error term. So, we will do the minimization error sum of square, which is nothing but summation y minus a cap minus b cap t, and that to square. So, now you have to minimize this error sum square with respect to a cap and b cap, like as usual simple regression modeling. And then after doing the simplification, so you will have actually only two different equations. The first equation will be like this, summation y equal to n a plus b summation x. So, here x is nothing but called as t, and y is nothing but the original variables, and by default your error sum of square so far as optimization is concerned. So, you have to minimize error sum of square with respect to a. Then if you simplify, you will have the first equation, that's here, and then we have the second equation when we actually differentiate with respect to b. So, there is a extra component in b. So, that will be multiply, and then you will have a second equation, summation x y equal to a summation x plus b summation x square. So, that means your spreadsheet will be having data like this y and then t. For simplicity point of view, since data is very consistent over the time, the first data point can be considered, that is with respect to time, can be considered as 1, then second time period can be 2, 3 and so on up to last unit. Then this will be treated as a x, then the rest you can actually simplify. So, now we need actually summation x and summation y, that means summation x instead of summation x, this is summation t, then we have summation y, and then you can multiply, you can have summation y t, and then we can have summation x square, and after the simplification we will have actually these two equations, and you put this value like this here, and then after simplification you will get the a value and b value, which you can actually analyze more details here, and that too with the help of this tables. So, this is what the kind of table here, and that means here the data it is a big data, we are just taking 5 data points, and here y is the means this is here and this is actually x, and then we have to actually predict y, that too with respect to x. So, that means this year is transferred into x, what I have already told you here. For instance, 1991 can be written as 1, 1992 can be written as 2, then this is can be written as 3, then 4 and 5, like this, whatever data we have. So, that means the first data, instead of writing 1991, so you simply write 1, then next data point year will be 2, and so on up to last data point, and then every times your actual y will be generated there. So, that means for year 1991 data is there. So, the data transformation will be, instead of 1991 8, we can write 1 and 8. Then again, instead of saying 1992 9, so we can say 2 and 9. Then again, in place of 1993, you can say 3 and 8. Like this, we have a different pool data, and then finally you can do the processing. So, now we will have here summation x, then we will have a summation y here, then again we can have x y, and that is what x y, and then x square, and then after that we can actually get sum x, sum y, summation x y, and summation x square. After having all these information, then you can actually move to this equation, and this equation will give you, for instance, now come to this equation here. So, this is the equation. So, now summation y, so you see here summation y is nothing but actually 50, then summation x is nothing but actually here 5. So, likewise you can actually, so here actually summation x, summation y, summation x y, and summation x square. So, now we put all these things and simplify. After the process, you will find the value of b equal to this much. Then now put this value in equation 1, you will get a value. So, ultimately the process will give you the value of a and value of b to do the trading. That's what here actually. So, now this is what the predicted line, this is what the predicted line now 5.2 plus 1.6x. So, that means technically 5.2 is the a and 1.6 is b. Not necessarily every time the coefficient will be positive, but maximum times the coefficient will be positive, and of course, the data will be tell you the real message what is the exact structure. So, that means technically what is happening, x is here actually used as time series structure. So, now say 1991 that becomes 1, 1992 that becomes 2, and so on. So, we have up to 1995 data. Then when we look for let us say 1996, then that means here is a 1996. So, we have actually let us say we can fill up here 93, then 1994. So, this becomes 3, this becomes 4, this becomes 5, and this becomes 6. So, now after having this one, so what will you do? So, we can have a predicted lines, and here just let us say 5.2 plus 1.6 into 1, similarly 5.2 plus 1.6 into 2 plus 5.2 plus 1.6 into 3, similarly 5.2 plus 1.6 into 4, and then 5.2 plus 1.6 into 5, and then finally 5.2 plus 1.6 into 6. That is what the immediate predictions next year. So, we have a data up to this, and then next year prediction will be 1996 will be this much. So, that means if you look very carefully here, this is very common actually. So, like we have intercept. So, the curve the structure will be like this actually. Finally, it will be like the 5.52 means this is the weight of intercept, and then with respect to time movement. So, the curve will may be starting like this. Of course, there is no need to draw this line. So, ultimately this can be movement will be like this also. It may means this will also clearly indicates that there is a alpha, since alpha is coming some positive value. So, that means it will be above than origins. If it is negative, then below than origins. If alpha is not there, that means the intercept is not there, then the prediction will be start from origin actually. This can be also true, otherwise it can be like this, it can be like this, it can be like this. Obviously, whether the movement will be up and down or negative. So, it depends exclusively on a coefficients, and that too it is derived through the data only. So, after getting this alpha a value, so we can get to know what is the position of this line starting beginning of that kind of structure. So, that means the first and movement, and then over the time the kind of predicted movement. So, now you just put 6 here, then that will give you the prediction about 1996, and then same we have already established this is actually common. So, the intercept and the kind of slope is common. Now, you just replace here in place of 6, if you put 7, then the prediction will be for 1997. Again, if you put 8, then the the prediction is for 1998. So, that means now having the past data or using the past data, we have actually build a kind of trend where the A and the B, the slope coefficients are more or less constant. That is what the average actually. That means that is the minimum weight which will carry through which do the kind of predictions. That is what the basic understanding of this trend lines and the kind of predicted line and the kind of average lines, and that too it clearly means it clearly highlights that every time. So, time series has a big boost to how you can actually easily get the trend lines or the predicted lines. Means simply without actually doing like this, just enter the data in Excel and scroll it, then you will find a generated data, and that is actually Excel software by default will read the kind of trend, understand the particular structure, then create a future kind of requirement. That is how the beauty of this trend least square mechanism, and that too by using actually linear equation only, but not necessarily we can every time use linear equations. That depends exclusively the kind of data on the basis of diagrams. So, that means we should first go for graphical visualization and get to know whether the fit will be with respect to linear ones or with respect to nonlinear one. So, now after simplification, so this is what the final predicted line. So, y equal to 2.0 plus 1.6x, and that too here actually the kind of predicted equation. So, what we can do actually we can actually check the difference the actual and the kind of predicted. Of course, the predicted is derived from the least square, and which is actually derived through a kind of process what we call as OLS mechanism. And now having the same data, you go for free and curve, semi average, moving average, and then again through least square mechanism, and every times to check the reliability of the model. Of course, you can in this particular least square mechanisms, you have to see that the parameters are statistically significant, goodness fit is okay, all kinds of diagnostic check. Then by the end of the day, so you will have actually forecasted line and the actual line. So, that means starting with freehand curve, then semi average, moving average, and the least square, every time. So, you have two different positions. One is the actual position and the predicted positions. Of course, actual position is very much common for all these mechanisms. The predicted position is slightly deviating, may be slightly deviating, because we are using different mechanism and different process through which we will get this line. but most of the instances keeping other things remain constant, more or less it will be actually better way of predicting the structure, and that too as per the particular engineering requirement. So, now not necessarily that the kind of trend line follow always in a linear structure. If not, then you can start with parabolic kind of structure. That is what called as non-linear kind of structure through which you can do the predictions. But of course, here is the same, x becomes t here. So, now instead of using y equal to a plus b x, so now we are using y equal to a plus b x plus c x square. So, that means same t will be there, y will be there. So, now we are getting additional one parameter, and that too with the help of dot product only. So, now with two variable case, the structural form will be like this. Here that's what the kind of game. So, this is two variables. So, we have two structural equation. Of course, it is derived from the Wallace mechanism, and if you go through actually the kind of three variable case, and this is how the three kind of structural equations through which you can do the predictions. So, now what is happening here? So, we have a y and then t and then t square. So, now you can start the game. So, some y, some t square, then some y t squares, then x square. So, that is how you will calculate, and then finally, you simplify, and once you simplify. So, now in the previous case, that too for bivariate, and that too for linear structure, we have only a and b. So, now we have a b c. So, ultimately the equation will be a plus b x plus c x squares, not necessarily positive. So, data will tell you whether the coefficient is positive or negative, and by the way data will tell you what is a value, b value and c value. Once you get to know what is a value, b value, c value and its nature, then you can actually simply means very easy way you can predict the kind of requirement. That is what actually basic structure of prediction with the help of least square mechanisms. So, that means least square is one of the standard mechanism through which actually we can derive a trend lines or predictor lines or the forecaster line, through which actually you can do some kind of engineering predictions or engineering forecasting. So, that means technically after knowing or after understanding the time series data, that to day wise structure, week wise structure, monthly structure, quarterly structure, annual structure, decadal structure. So, means these are all various forms of time series data, and when we start with day wise, then week wise, then monthly, quarterly and annually, semi annually. So, these are all various labels actually, means what we can call as time series reporting. And when we start with that means let us say have data with respect to day, then data with respect to week, data with respect to say month, data with respect to quarterly, and data with respect to annually. Of course, the data with respect to day have a huge sample, then the sample will be slightly low, and instead of day wise data we may have weekly data. Again the sample will be very small, instead of week wise data if you use monthly data, again the sample size will be very low, and instead of using monthly data if you use annual data, because for a annual data, so we like to follow moving average concept, like 12 years 12 data points to become a single unit. So, that means when we do some kind of normalizations, like moving average or something like that, so you should actually logically connect every time. So, the once logically you can establish, yes, this can be done and there is no such big error. So, you can proceed. Of course, the error may be there in the system, which we can actually test later stage. Once you get the predictor line, and try to compare and contrast with actual line and then check the difference, whether the difference is actually coming very minimum. So, if that is the case, then by default you can declare that this is the predicted line through which you can do the predictions, and that too with the help of time series data. So, we have means first hand we have a time series data, and there are various mechanisms, and now using this time series data under different mechanisms, we can have a different kind of predictions and different kind of forecasting. So, that means by default it gives some kind of robustness here, the same data with respect to same time period. So, we are having different kind of prediction structure. Then graphically means all these possible through graphically, just have the predicted structure and draw the predicted line. So, now ultimately means we have already discussed various mechanism through which you can declare which one is the best. And by the way, starting with freehand curve to least square mechanism, this mathematical mathematically we are improving actually. So, that means in the first case freehand curves there is no mathematics, simply you just check the highest point, lowest point, and blindly actually just draw a line in between. It will not cross upper up peak, and it should not again cross the peak at the bottom side. So, it will be parallelly in between. So, if that is the case, you can do the kind of better prediction. So, so all these things are very valid to do the forecasting, and you can every time check and compare. So, one way of robustness check to justify that the model is very good or can be used for any kind of engineering forecasting is that you check means draw the line with respect to actual, then you slightly inspect that there is a which one is the much better. That is called as graphical visualization, but parallelly you can do some kind of quantification by calculating the forecasting error, which is actually difference between actual y and predicted y, and usually the sum of actual sum of the difference between actual and predicted line should be equal to 0. If that is the case, in the first instance you can say that the particular predicted line will be the best for the forecasting or the kind of prediction. If not, what will you do? You have to find out forecasting error actually. So, then after that you will compare with all these methods differently, then you check where the forecasting error will be actually minimum. If it is 0, then by default that will be the best. If not 0, then how much error is coming, and how which methods the error is actually very minimal, and that will be by default will be used as a kind of engineering predictions or kind of engineering forecasting. We have lots of forecasting tools through which you can declare that the particular model is very good to do the predictions, like mean error, mean percentage error, mean absolute percentage error, root mean square error, like we have various indicators through which you can declare that this model is actually good for the prediction and forecasting. So, which means which will mean the detail about this indicator through which you can check which one is the best model for the prediction and forecasting. We will discuss the details in the next lecture, and in the meantime we will stop here. Thank you very much. Have a nice day.